Hello and welcome. This is Wahsa Distance Education's radio Zoom classes, and today we're doing MBF3C, grade 11 college math. I am Bronwyn Slate. Want to make sure that everyone knows how to participate live if they want to. You can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You can also join us live through Zoom, and the link is available from me, your teacher, and from your DEC. I've turned on the subtitles, so just so that you know how to turn them on or turn them off if you'd like to, down at the bottom of your Zoom screen, there is a more or a live transcript depending on your view, and then you can click hide subtitle or show subtitle depending on what works best for you. Our classes run from Monday through Thursday from 11 until 12, and we are just wrapping up our first week out of our 9-week course. I want to remind you what work to submit for me to mark. The support questions, the ones marked with a pencil icon, are not for marking. They are just for practice for yourself. You decide which ones and how many to do. They're all there for you. But if you understand the concept, feel free to skip questions and spend your time working on more challenging concepts. The answers are in the back of your package, so check your work to make sure you're on the right track. Sometimes answers or questions have typos or errors. So if you find anything that doesn't line up, let me know and we will look at it together. The key questions marked with a key icon are the questions that you submit for me to mark. So please do all of them and show all of your work, including all of your steps and your thinking, so that I can give you credit for what you do understand. And if you're making small calculation errors or something, I can tell because I can see all of your thinking and all of your process. Submit your work for marking. There are 3 methods. First, you can scan and send it electronically. So scan all of your work through either the iPhone Notes app or the Android Google Drive app. Then you can send it as one file. Email it to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can also send it through Facebook Messenger to bslate. And also drop it off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street, the side entrance for the big red building next to the post office. And there's a small white mailbox next to our side entrance. Third, you can hand it into your DEC. Your DEC can then either send it through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. As always, if you have any questions or concerns, please contact me. I am here to help. That's what I spend my days doing. You can email me at bronwyn.slate, spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at bslatewahsa. You can call the office and leave a message there for me at 807-737-1488. It's best to leave a message with the front desk, as I don't have access to my voicemail while we're working remotely. You can call there toll-free, 1-800-667-3703. And my office hours are Monday through Friday, 8 a.m. to 2 p.m. and I will try to get back to you as soon as I can. Connecting with me through social media. My Facebook again is bslatewahsa. You are welcome to friend me and we can chat there. Also subscribe to my YouTube channel, which also is the name bslatewahsa. Will be posted after it's aired. And I also have short videos on my YouTube channel that explain common errors or confusing concepts, both that are from our course, but also prior knowledge, things that people make mistakes with over the years. So go check that out if you might need some help with something. Math is a very visual subject. So if you can connect either through the Zoom lessons or watching the YouTube channel lessons afterwards, that is going to set you up for the most success. So please try to connect. Today's lesson particularly is very, very visual. We're going to be using Algebra Tiles again, and being able to see what's going on is really, really helpful. So please try to connect with the video. All right, today is day 4 of our MBF3C course, and we are continuing with lesson 2. We will wrap it up today. We're going to be focusing on factoring today. A recap of our learning goals. At the end of this lesson, I hope you can say, I will understand and implement the distributive law, and I will be able to factor trinomials. We focused on the distributive law yesterday or last class, and we'll be focusing on factoring today. Our success criteria. You can say, I know I have met the learning goals because I can explain and identify polynomial terminology, I can multiply binomials, and I can common factor and factor trinomials when A equals 1. All right, let's activate our brains and do a little bit of mental math. As we have discussed, many of us experienced mental math mad minutes when we were in elementary school, and they caused a lot of stress and didn't help us learn our arithmetic facts or how to do mental math or arithmetic in general. So we are not going to be doing that, but instead we're going to be engaging our brains and developing strategies. Today we're going to be looking at a division question, and long division is, many folks are not fans. And so we're going to, over our course, going to be developing a few different strategies. Today, we're going to start with thinking about it as sharing in groups, which many of us start with. So instead of, when I started to learn how to divide, I created myself a bunch of groups and then shared out my objects one by one by one, and that can take a lot of time. So what we can do instead of is we can think about that as sharing out our amounts in a friendly number groups. So this question, 30 divided by 5, we can think about just grouping in 5 and figure out how many groups we end up. So if I say 5 and then 15 and 20, 25, 30. So I've counted by 5s. I've shared out 5 objects at once or groups of 5, and I've figured out that I have 1, 2, 3, 4, 5, 6 groups. Many people do this, particularly with counting with 5s, but you could do this with any other number. So you could do this if you're counting by, if you're dividing by 7, or if you're dividing by 3, instead of either counting by 1, 5s, or 10s, which are common numbers, we could share out in groups of 3s. We also could share it out in a mixture. We could share it out by first sharing out groups of 5s and then sharing out in smaller groups, if that worked as well. We'll maybe look at that another time as another example. All right, minds on, engaging our prior learning. We're going to recap what we did at our last lesson. So we multiplied, the main focus that we did, the bulk of our lesson was multiplying binomials. So here we have an example of 3x minus 7 all times 5x plus 2. Did that using algebra tiles, but we also did that using the box method, which is I'm going to recap today first. So 3x times 5x is 15x squared, and 3x times positive 2 is positive 6x, and negative 7 times 5x is negative 35x, and negative 7 times 2 is negative 14. So we can see that we've multiplied each of our parts by each of our parts, and we get this 15x squared plus 6x minus 35x minus 14, which we then combine our like terms. Our x terms are our like terms, so we end up with 15x squared minus 29x minus 14. So that's what we did yesterday. We're also going to, we need to remember factors for this lesson. Factors is terminology that would have been introduced in elementary school, but isn't something that we necessarily use a lot. So when we think of a simple problem, 2 times 5 equals 10. Our 2 and our 5 are factors of 10. So 10 is our product, and 2 and 5 are factors. They are not the only factors of 10, but they're one example of the factors. So the factors are what multiplies to be our product. So looking at what are all the factors of example 24. So we're looking for what are the numbers, pair of numbers that multiply to be 24, and those numbers are our factors. So 1 times 24 equals 24. So our factors include 1 and 24, but also -1 times -24 equals +24. So -1 and -24 are also factors. 2 times 12 and -2 times -12. 3 times 8 equals 24, and -3 times -8 equals 24. And 4 times 6 and -4 and -6 also equals 24. So our factors of 24 are positive and -1, positive -2, positive -3, positive -4, positive -6, positive -8, positive -12, and positive and -24. So those are all of our options if we're looking for numbers that multiply to be 24. It takes practice to know what all of your factors are. Sometimes you miss some, sometimes you're spending a lot of time trying to figure out more and there aren't more. It just takes practice to get comfortable, and that's why those brain activations that we're doing and getting comfortable with numbers is really important, because then we can spend less time on figuring out the factors and more on the applications of that information. Okay, active learning, we're going to be exploring our new concepts today. And that is factoring quadratic relations in the form of ax squared plus bx plus c, where a equals 1 is where we're going to start. That doesn't need to mean much to you right now. That's okay. This is on page 13 in your IL book. So connecting it to what we've been doing, we were expanding yesterday where we had our binomials, we were multiplying them together, and we got our trinomial as our answer. And we did that using algebra tiles or the box method. So we had our binomials on the outside with our algebra tiles, and what ended up being on the inside was our trinomial was our answer. When we're factoring, we're going the opposite direction. So with our trinomial, we're starting with the inner rectangle, and we are trying to figure out the parts, the factors, the two numbers, the two sets of terms that multiply to be that amount. So we're going backwards to find those binomials compared to what we did yesterday. So how we start when we have a question, we're going to start with algebra tiles, and then we will figure out how we do it without algebra tiles. But the first thing we're going to do is we have our question, x squared plus 7x plus 12, and we're going to represent that with algebra tiles just so that we can visualize what's going on. So x squared, we have 1x squared term. 7x, we have 7x tiles. And then 12, we have 12 unit tiles. So we've gathered our tiles, and now we need to organize them to figure out what it is, how we can figure out what two binomials multiply to end up with this set of tiles. To do that, we need to remember back to when we were yesterday, when we were expanding our binomials, that every single time with our algebra tiles, we ended up having a very crisp rectangular shape. So our tiles were organized in a way such that they looks like a rectangle. So every binomial is going to end up organizing your tiles in a rectangle shape. And we're going to use that to figure out how to factor with algebra tiles. So we need to organize our tiles such that they look like a rectangle, basically. So how we sort of write this while we're paralleling that with organizing algebra tiles is that our first step is that we know that we're going to have two binomials. That's what we're starting with. When we're factoring, we're going to end up with two binomials. So I always start with writing out my two sets of brackets, and then we're going to organize our information, which is a little slightly different than how we often write out algebra, but our binomials, two sets of brackets are where we're going to start because we're multiplying two different things and we're trying to figure out what goes inside those brackets as our binomials. So looking at x squared, the only way that we can get x squared is by multiplying x by x. So our first part of our binomial is going to be x and x, because the only way we can get an x squared term again is by multiplying x by x. That's fairly consistent. That's going to be a pattern that you're going to notice shows up most of the time. So then to figure out what goes in our second part of our terms, we need to look at our other tiles, our x tiles and our unit tiles. So how we do that is we're first going to be looking at our constant, our number at the end, and we're going to think about what two numbers multiply to equal 12. So what are our factors of 12? So when we think about when we were multiplying our binomials, we would multiply our two numbers, and that would give us our constant. So we're going to rearrange our tiles in the arrays that show us our factors. So we have 1 by 12 is one way we can organize our tiles. 2 by 6 is another way we can organize our tiles, or 3 by 4 is a third way we can organize our tiles. And you'll see those are the factors. 1 and 12, 2 and 6, 3 and 4 are all of our factors. So the second part we need to think about, now that we have to think about these in conjunction, we need to add up our tiles such that we end up with 7 x's. So we need one of these arrangements to help us figure out that we have 7 x's. How can they relate to these three arrangements? It's a little bit tricky, but keep with me and we'll get there to when it starts making sense. So there's no way that I can take these 7 x tiles and arrange them such that I have a number times a number is going to give me 1 times 12. There's no way that I'm going to get 7 x tiles. So this 1 by 12 option is just not going to work for us. So we're going to leave that one for now, and we're going to look at these other two options to see what I'm talking about. So first we're going to look at this 2 by 6 option. I'm going to take my x tiles and I'm going to arrange them such that they are starting to make a rectangular shape. So I'm going to say for every row, I'm going to put an x tile and see what happens. So I have 6 x's go for the rows, and then for my columns, I only have 1 x left. I don't have 2 x's, which is what I would need in order to make that rectangular shape that we're aiming for. So that can't work. We can't have 2 and 6 can't. There's no way that we can. 2 plus 6 is only gives us 8, doesn't give us 7, so we can't get 7 x tiles. Okay, so we have to look at our third option, our 3 by 4 option. Again, we're going to take our x tiles and we're going to arrange them such that they line up with our unit tiles. And we have 3 for our rows, and then we have 4 for our columns. And you can see on the visual that our 3 x's and our 4 x tiles line up with all of our unit tiles such that our rows and our columns are lining up. So if we slide that over to our x, we can see that now we have this rectangular shape, which when we think back to our multiplying our binomials is what we would result in. So that means our answer, we need to add 3 to one of our x's, and we need to add 4 to our other x in order to result in this rectangle of an answer inside. So x plus 3 is our one binomial, and x plus 4 is our second binomial. And that's our answer. That's we've factored our trinomial x squared plus 7x plus 12 equals x plus 3 times x plus 4. We're going to do another example because this is tricky stuff. So we're going to do a few examples. Now we're going to factor x squared minus 5x minus 6. So our first step is to get all of our tiles. So x squared, 5 negative x tiles, and 6 negative unit tiles. We think back to the fact that we know we want it to be in a rectangular shape, so we're trying to organize it such that it'll be a rectangular shape. That's our goal. Our first step is to think the fact that we're looking for 2 binomials. We're going to set up our brackets, knowing that we're trying to fill in those 2 binomials. We're going to remember that x squared, the only way we can get an x squared is by having an x times x. Our first part of our binomials has to be x and x, because that's the only way we can get an x squared term. Then to start figuring out our second part of the terms, we think, okay, what 2 numbers multiply to be -6, our constant. So we're going to organize our -6 in all of its factor arrays. So we have 1 by 6, and we have 2 by 3, and those are the only 2 arrangements that we can make. So now we are going to be looking at what our tiles need to add up to, what our 2 numbers need to add up to, is we need to have -5x is what we need our numbers to add up to in order so that we can create that. So we're going to look at our two options. So first we're going to look at our 2 by 3 option. To take our tiles and move them such that they line up with our 2 by 3 array. So this looks pretty good. We have 3 tiles in our columns and 2 tiles in our rows. So that looks like it's going to make our rectangular shape, which is what we want. The trick is that in order to get a number times x, a positive number, to get a negative result, we need to have a negative times a positive to get that negative result. And again, we would need to have, for both of our terms, that would be true. In order to get these negative x tiles, we need to have negative numbers in order to multiply by our positive x. But then we would have a negative number and a negative number, which would result in a positive units, and we actually have negative units. So that can't work because a negative times a negative equals a positive. So we can't arrange our tiles even though they line up. If we look at our signs, that isn't going to work. If we had -3 as our term, if we had x minus 3 and x minus 2, when we multiply -3 and -2, we would end up with +6, not -6. So that can't work. Let's look at our other array to see if we can make that one work. So we have 1 by 6. We're going to line up our tiles. We have our 5 negative tiles, sorry, our negative x tiles, and they line up. But it looks like we've run out. We have our 5 in our columns, and we have 1 more column space, and we have our row space that doesn't have anything. And so what are we going to do now? But if you think back, sometimes when we were combining our like terms, we would end up canceling out our negative and our positive x's. And so we have to think that there's another way that we can do that. Maybe we canceled something out. So we're going to introduce what is called a 0 pair. So it's like we have 0, that we don't want to change our number of x tiles, but if we introduce a positive and a negative tile, that's like introducing 0, because that doesn't actually change it. Those cancel each other out. So then we can take those tiles and use them in our array. So we have our positive x can go in our row and our other negative x can go in our column. And that ends up making our rectangular shape. It fills in all of our holes. And we have a positive times negatives is going to give us a negative. So we shift that and that fits to our rectangular shape. It makes that shape that we were looking for. So we end up having a 1 gives us all of the positive x and the 6 or in the units, and then our having 6 negative units for our other binomial gives us the negatives and the negative units. So that results in x plus 1 being our first binomial and x minus 6 being our second binomial. So these, using the algebra tiles, you can now, if you want to pause the video and do the support questions on page 14, questions 6A to C. And using the algebra tiles, you can go to the Polypad. I will link the virtual manipulatives into your show notes. And then you can use those to try out these questions. Again, the algebra tiles are really useful visualization, but are also can be a little bit tricky. So we're going to look at another method with just algebra in case you don't have access to tiles or the visualization doesn't help you. Oh, but before we're going to do that, I forgot. We're going to factor quadratics when a doesn't equal 1. And we're not looking at all the options, but we're going to look at something that happens because that does show up. So in this question, we have factoring. We're supposed to factor 2y squared minus 12y plus 16. And here we have a 2 in front of our y squared term. And so we have to figure out what we're going to do with that. Showing what that means is that we have 2y squared tiles. And then the rest of our tiles, we have negative 12y tiles and then 16 unit tiles. So we have to figure out how we can factor that when we have 2y tiles because we haven't, sorry, 2y squared tiles because we haven't done that before. But what we can see actually is that we have 2 identical groups. We have y squared minus 6y plus 8 twice. They're exactly the same thing. So we can factor out 2 and break our groups up into smaller, simpler groups to factor because we have the same thing actually twice. This is called common factoring. If you can common factor, it's always going to make your life easier. And you can still factor otherwise, but if your numbers are going to be larger and it's going to be harder to handle. So if you can common factor, always common factor first. So now how do we factor once we've common factored? So we have all of our tiles. Once we've common factored them out, then we can say that 2y squared minus 12y plus 16 is equal to 2 times all of y squared minus 6y plus 8. So we've factored out that 2 from each of these terms. And now we can just look at one set of these things, which of this trinomial, and that's going to make our life easier for factoring. So we're going to organize our tiles like we've done before, but this time we're just doing it with the smaller group instead of the whole amount because we know we're just going to end up doing this twice. So we have our binomials and we're going to keep that 2 in front. So we're still going to set our 2 sets of brackets, but we're going to have that 2 in front to remind us that we're actually doubling this. Y squared, still the only way that we can get y squared is by having y times y. So that's our first part of our term. And our second part, we now are looking to times y times 8. The original number was 16, but because we factored that 2 out, now we're just looking at the smaller part that is in our second step. So we're just looking to see what 2 numbers multiplied to be 8. So our options are having 1 by 8 or 2 by 4. And you have to remember that we're looking at what 2 numbers are going to add up. to be such that we get negative 6y as our other term. So we arrange our tiles. First, we're trying out 1 by 8. We've arranged our 6y tiles. We still have 2 vacant y spots in our rows and 1 vacant y spot in our column. And so we think, okay, can we do a 0 pair? If we brought in a 0 pair, would that make this work? Well, if we brought in a 0 pair, we would get 1 negative and 1 positive, but then we'd still need 1 negative spot. So that doesn't work. We can't do that. We have to, when we bring in a 0 pair, we always are going to get a negative and a positive. So we can't only get half of that. So 1 by 8 isn't going to work. So let's look at 2 by 4. 2 by 4, we take 2 and we're lining up our y tiles with 2 by 4. And we look and they line up really, really well. We end up having the exact number that we needed to. We have 2 horizontally and 4 vertically. And so we then check, we have a negative times a negative, which is going to end up being a positive. And so that works. This time we can do this. So we shift it into our square tile and we see we have that nice rectangular shape, which is what our goal is. So we have y minus with 2 units, and then we have y and we have 4 negative units. So our terms end up being y minus 2 and y minus 4. So our answer is 2 y minus 2 times y minus 4. And that's our final answer. So now, if you want to pause the video again and go on page 14, what we just did will help you with questions 6H and I. All right, so now we're going to factor without visuals. If you don't have access to the algebra tiles or you would like another option and you just want to do it with algebraically, this is how we would go about doing that. And this is on page 13. So our question that we're going to work with is x squared minus 16x plus 63. So as I said before, our first step is always a common factor. Can we make this any simpler before we go on? We look at our x squared term and our coefficient of our x squared is 1, which means that we can't factor anything out of that term. So then we can't common factor. We have to common factor each and every term. If we factor out a number, it needs to come out from each of our terms. If we think back to the algebra tiles where we're sorting them, they have to be exactly the same. So we can't common factor. So then we're going to set up our step 2 is to set up our double brackets, knowing that we're going to end up with 2 binomials. That is our goal. Our squared term is the variable that goes in the first spot. The only way we can get x squared is have x times x. So that's what goes in the first spot. Now we're looking at what happens with the second spot. So step 4, we asked ourselves, what multiplies to be the constant? What times what equals 63 for this example, positive 63. To do this, we need to find all of our factor pairs. So we have to think of what are all the numbers, sets of numbers that multiply to be 63. Again, this can take some time. So we have them written out: 1 times 63, -1 times -63, 2 times 21, -3 times -21, 7 times 9, -7 times -9. I generally sort of how I do it is I think about it. I sort of start with 1 times whatever my product is, and then I sort of work successively from there to make sure that I'm not missing things. So I check this 2 times it. No, that doesn't. 2 times nothing is going to equal 63 because we're looking for whole numbers. And then I sort of progress from there. Again, it just takes practice and comfort. So step 6, we ask which of these factor pairs adds up to be the coefficient of the middle term. So which of these factor pairs adds up to be -16 this time? So then I look at my factor pairs and I combine them. So 1 plus 63 is going to give me 64. Nope. -1 plus -63 is going to give me -64. Nope. 3 plus 21 is going to give me 24. Nope. -3 plus -21 is going to give me -24. Nope. 7 plus 9 is going to give me +16. So we want to say yes, but we're looking for negative 16. So negative 7 plus negative 9 is going to give me negative 16. So those are my two numbers that are going to make this work. We'll go into our second spot. So x minus 7 times x minus 9 is how I've actually factored, is the two binomials that if I multiply together are going to give me x squared minus 16x plus 63. Okay, let's do another example. Our example is 7y squared plus 21y minus 28. Our first step is always to common factor. Can we make our lives simpler? So we look at our y squared term, and our coefficient of that is 7. So isn't 1, so chances are pretty good at this level that we're going to be able to common factor that out to make our life simpler. So I look at each of my terms and I say, okay, if I factor out 7 times y squared gives me 7y squared. 7 times 3y gives me 21y. And 7 times negative 4 gives me negative 28. If I had algebra tiles, I could share them out and I could end up with this. Otherwise, I need to look at what numbers are going to multiply to get my resulting ones and figure that out. It takes a bit of practice. Then our step 2 is writing our double set of brackets. We have this 7. We're going to keep that because we factored that out, but we're going to end up with our 2 sets of brackets. Now, step 3, we say, okay, our squared term is the variable goes in the first spot, y squared. The only way we can get y squared is by getting y times y. That's our first part of our 2 binomials. And then trying to figure out our second part. We ask what multiplies to be our constant. So what 2 numbers multiply to be negative 4? We find all of our factor pairs. 1 times negative 4 equals negative 4. Negative 1 times positive 4 equals negative 4. And 2 times negative 2 equals negative 4. We don't have to write negative 2 times 2 because it's the same thing as 2 times negative 2. So we only have 3 options this time. Then we ask ourselves, which of the factor pairs adds up to be the coefficient of the middle term? What adds up to be positive 3? 1 plus negative 4 is going to be negative 3. So that doesn't work. We want positive 3. Negative 1 plus 4 gives me positive 3. So that works. And 2 plus negative 2 gives me 0. So that doesn't work. So the one that we want is negative 1 plus 4. And I have a video on my YouTube channel that is a helpful reminder about adding and subtracting negatives. I'll link that in the show notes because that's a place that people often make mistakes as well. So negative 1 plus 4 are our 2 numbers that go in our second places in our binomial. So our answer is 7 times y minus 1 times y plus 4. And then we factor it in. So that example will help you with your support questions on page 14, questions 6, D, and G. Sorry, D through G. Okay, so we're going to consolidate some of this learning. We've done a lot. So we're going to do some more practice problems and to make sure to see where we're at. So highlights of lesson 2 completely. So polynomials and factoring. So a recap of what we did as well yesterday, just a quick reminder. So we expanded using the distributive law, where we multiplied each term inside the brackets by the term outside the brackets. And then we expanded and simplified binomials using the distributive law, where we used algebra tiles in the box method, and FOIL is another option. And then today we factored quadratic relations, where we common factored if it was possible. Then we found all factor pairs of the constant terms, what 2 numbers multiplied to be the constant term, and then identified which of those factor pairs adds up to be the coefficient of the middle term. That's what we did today. The first 2 highlights, we met with the success criteria yesterday in terms of you can say, I can explain and identify polynomial terminology, and you can multiply binomials. And then today we met the third success criteria, hopefully, where you can say I can common factor and factor trinomials when a equals 1. So let's do some practice questions. So we're going to expand. Question says, expand -5 times y minus 3 times y plus 6. So this question says to expand, which means that we are multiplying out our numbers. We're not factoring, which is what we did today. So we have to read what the question's asking and make sure that we're doing the right operations. So this expanding is like what we did yesterday. Because we have -5 times our two binomials, we're going to have to do this in 2 steps. So personally, I like to do my coefficient, binomial by my binomial first, mostly just because it comes first. But remember, you could do your 2 binomials first if you wanted to. I'm going to do -5 times y, take away 3. And that I'm going to say, okay, -5 times y is -5y, and -5 times -3 is plus 15. Okay, so I've done the first step. So now I have -5y plus 15, and I want to multiply all of that by y plus 6. So my step 2 is multiplying these 2 binomials now. And I'm going to do the box method is my method of choice. So I have -5y plus 15 and y plus 6. So then I have -5y times y is -5y squared. -5y times positive 6 is going to be -30y. Positive 15 times y is going to be positive 15y. And positive 15 times 6, that's not one that I know automatically in my head, but I know that 10 times 6 is 60, and I know that 5 times 6 is 30. So 60 plus 30 is 90. If you want to use a calculator, totally fine. So then multiplying these 2 binomials, I'm going to write out all of my terms from the box just so that it's all organized. So I have -5y squared minus 30y plus 15y plus 90 equals -5y squared, -30y plus 15y. I think about this as I'm at -30 degrees, which we are, and we add 15 degrees, which would be dreamy, but we'd still be at -15 degrees. So -15y plus 90. And there we go. We've expanded -5 times y minus 3 times y plus 6, and we have gotten -5y squared minus 15y plus 19. Okay, next question, question 2. This question asks us to factor y squared plus 13, x squared plus 13x plus 40. Okay, so how are we going to do this? My bad. I know I look first, can I common factor? Do I have anything in front of a coefficient in front of my x squared term? I do not, so I can't common factor. There's nothing common to all 3 terms. So I know that I'm going to end up with my 2 sets of binomials. And so then first I look, okay, what multiplies to be 40? So my factor pairs, I'm writing this down sort of separately from my question. So my factor pairs of 40. So 1 and 40, -1 and -40. 2 times 20, -2 times -20. 3 doesn't go evenly into 40. 4 goes evenly into 40. So 4 and 10 and -4 and -10. 5 and 8 and -5 and -8. And 6 doesn't go evenly into 40. 7 doesn't go evenly into 40. 8 we already have. 9 doesn't go evenly into 40. So I'm going to start, there might be something else, but maybe not. I'm going to start looking at these options first before I try to find more factor pairs. So then I ask, okay, what of these factor pairs adds to be positive 13? So 1 plus 40 is going to be 41, -1 plus -40, -41. So none of those work. Two plus 20 equals 22. That doesn't work. -2 times, plus -20 equals -22. That doesn't work. 10, so 4 plus 10 equals 14. Getting closer, but that doesn't work. And -4 plus -10 is -14. 5 plus 8 equals positive 13. There we go. That's the one we want. Doesn't always, it ends up being one of the last ones. That just happens to be what my questions, my examples were. I forgot that for our first part of our term, the only two things that are multiplied by x squared are x plus x and x. So my x goes into the first part. It's okay that I forgot that and just did it now. And then I'm going to have plus 5 and plus 8 as my numbers in my term. It does not matter if you were to write this as x plus 8 times x plus 5. The order doesn't matter. Both are the exact same thing. It's like saying that 2 times 3 is the same as 3 times 2. So it doesn't matter. So these are both valid answers. And there we go. I'm done. A lot of this work happens in your head or separately when you're factoring, and then your answer just can be sometimes looking very, very short. All right, then we're question 3 for our practice questions. It says expand 4x plus 5 all squared. So we haven't done one of these questions. Expanding means that I'm going to be multiplying it out. So this is like we were doing in last lesson. So when I see this here and I say, what folks often want to do is they just want to square the first part and square the second part and say that they're done. But when I'm squaring, that means I have this whole thing twice. So what I'm going to do is I'm going to write it out twice. So 4x plus 5 times 4x plus 5. And we see that if we were just to do 4 squared, 4x times 4x, and then 5 squared, 5 times 5, we would miss the other parts in there. So we need to make sure that when you see something squared, if you see a binomial squared like this, you want to multiply, you want to write it out so that you multiply every part. I'm going to do the box method because that is my tried and true method. If I had algebra tiles, I might do that, but generally the box method works for me. So 4x plus 5 times 4x plus 5. So 4x times 4x is 16x squared. 4x times 5 is 20x plus 20x. 5 times 4x is plus 20x. And 5 times 5 is plus 25. So then I'm going to write out all of my terms. 6x squared plus 20x plus 20x plus 25 equals 16x squared plus 40x plus 25. If you're comfortable going from the box directly to this last line and not writing out the 220x's and just writing out 40x, combining your like terms in that step, that is totally fine. You do what works best for you. If you are consistently making errors, then I might suggest that you break it up and write out that middle step, but that's fine if you leap over that step. And then our last example, we're going to factor negative 10y squared plus 80y plus 200. So we want to look first and see if we can common factor. We have a coefficient of -10. So we're going to common factor -10 out. So -10, and I have to think about what multiplies to be these other terms. So -10 times y squared. It's my first. Then -10 times what gives me 80. So that's going to be -8y. And then -10 times what gives me +200. So that's going to be -20. Again, that is something that I'm comfortable with. If you want to use calculators, that's fine too. So I've now common factored it out, and these numbers are a lot more friendly for me. So I know that my first step is I'm going to have my two sets of brackets, but because I common factored out that -10, I need to do that first. And then I know that my y is going to go in the first part of my two brackets, because the only way I can get y squared is by multiplying y by y. Then I need to think of what two numbers multiply to be -20. So my factor pairs are 1 and -20, and -1 and 20, and 2 and -10, -2 and 10, -5, and -4. My factor pairs where we're going to start. So then I need to think about what adds to be -8. Remember, we're looking at our common factor trinomial. And I have to think, okay, so 1 minus 20, that's not going to be -8. -1 plus 20, that's not going to be -8. 2 minus 10, that is going to be -8. That's going to be -8. So my two numbers are 2 and -10. So I put them in my follow-up in my binomials. And you can see I wrote -2, but really I want +2, because if I have -2 plus 10, that's going to give me +8, which is not what I want. So it needs to be y plus 2 and y minus 10. It doesn't matter if you were to write y minus 10 and then y plus 2. That order doesn't matter, but your sign has to go along with the right the number, because -2 is different than 2 than +2. -10 is different than +10. And then factored, then we're done. You could multiply it back out to check it, expand it like we were doing before, but that's all. That's the end of our factoring. All right, so we got in today. If you have any questions, please, as always, feel free to contact me, calling and leaving a message for me at the office at 807-737-1488 or toll free 1-800-667-3703. Emailing me at bronwyn.slate@nnec.on.ca or Facebook messaging me at bslatewahsa. This lesson will go up on YouTube, so you can watch it again and slow it down, pause it, take breaks, go back. So please do that. It's a lot of information today, and so going over it again is probably a great idea if you're struggling. Thank you so much for joining me today, and I hope you'll be back with me next week. Miigwech, and have a great day.